Okay, so switch versus hub. Switch is a little smarter, cuts the traffic down. It's still on the same. A switch is a particular kind of a bridge. A switch is a N-way. Well, an N-way. Now, when I say N-way, it's like a four-way or a two-way or a three-way. It is an N-way bridge. Can anyone define what a bridge is? A bridge. A bridge is a simple device that connects two identical kinds of networks. Connects two identical kinds of networks. So on a switch, if you've got a switch, and it's got 4 ports, each one of these ports is a network. It's actually a network segment. But this switch connects all 4 networks, and it routes packets. It transfers packets from one network to the same. Now when I say identical, I mean it has the same electrical properties, it has the same transport properties, TCP/IP properties, it has the same protocol. It has an Ethernet protocol. The next kind of thing that connects all of these things, bridges, routers, and gateways, they all connect networks. The difference between the 3 types of devices is the 3 kinds of networks that they connect. This is a definition that is for this class. If you go into networking, or if any of you have ever spent any time in networking, you'll realize that what I'm telling you is an oversimplification. Networks are like that. Just like when we talk about programming, I'm going to simplify things just so we can talk about it as a first introduction. So a bridge connects identical networks. Same transport layer, same protocol. A router connects 2 networks of the same protocol. So a router is the thing that connects your house to Comcast. Remember we had a discussion about static IP addresses and dynamic IP addresses. You had one set of IP addresses inside your house that was your local area network. You have a router that connects your network to the Comcast network or the Qwest network, whatever Qwest is calling themselves this week. This is what the router translates packets. A bridge, as you saw, doesn't do a lot of translation. About the most thing that a one-way bridge, all it does is pass packets back and forth. A switch just routes those packets to the right port. It doesn't change those packets at all. A router is one of those things that says, oh, this guy wants to send this to an IP address, and that IP address isn't on my network, so I'm going to route it to some other network. This is the next layer of a smart device that interprets packets and translates them. So this is packets, translates packets. But it's got the same protocol. And for an example of that, is they're both Ethernet. A gateway, for the purposes of this class, is a device that takes packets from one network and sends them to another network, except now the networks can have different transport layers and different protocols. So a gateway translates the packets, and it's even smarter. This will go to different protocols. So, for example, you would use, if you have here's a star network, here's a switch, and you've got a bunch of, I don't know, PCs here. And you've got a token ring network. Token ring networks are kind of cool. On a token ring network, the reason a token ring used to be the hot setup. Remember we saw a switch. Each guy is sending packets back and forth to the switch. The switch decides, well, where am I going to route that packet to? On a token ring network, and early on, 20, 30 years ago, that was too much. We couldn't do that quickly enough to make a good, fast network. And the first networks like this were only 10 megabits. If you wanted to go faster than 10 megabits, you used one of these. It's faster, or it was faster, because the NIC on this device, every device had 2 NICs. And each NIC was responsible only for listening to one other NIC. It's a very simple job to do. It would always take every packet that came in. It never discarded any packet. The trick that it would do inside this device is if it didn't have my address, I'd send it down the road. So packets were constantly flying. If I wanted to send a packet from this device to this device, I'd send it downstream. We'd go to this device and say, that's not mine. Send it to this one, send it to this one. Finally, it'd say, oh, this is my packet. This is my address. I'll take this packet. And it wouldn't send anything else. The electronics and the processing was far simpler. And so this token ring network could run a lot faster, 50 megabits, 100 megabits, something like that. 10 times faster is always a good deal. Token ring networks still exist, and they are pretty fast. What's happened though, because of Moore's Law, does anyone here know what Moore's Law is? You're not going to share with me if you do. Moore's Law is that transistors get half as big every 2.5 years. Right? The number of transistors you can put in a device doubles every year and a half. Every year and a half. That's why current microprocessors have millions of transistors in them, when the first microprocessor only had thousands. Well, because they get smaller, they get faster. So as these network devices have used better and better processors, they've gotten faster and faster and smarter and smarter. So now I can make switches that are hugely fast. What did we see the other day? 10 gigabits. What's your switch? It runs 100 megabits at least.
Yeah.
And that's a consumer level switch.
It'll go up to
1,000 megabits switch. Higher protocols can do 100 gigabit switches. These are fast switches. And not only they're fast, they're also real smart. They're looking at the packets, they're enforcing security, they're doing all sorts of things. People spend money on infrastructure, so you still see token rings around the world. People still have that stuff installed. I don't know if anyone's installing new token rings. Maybe there's a good reason for it. I'm not a network guy. In any case, this is an entirely different protocol here than this. If I want to send packets from this PC over to this server or this PC, I've got to route it through what?
Gateway.
Through a gateway. So I need a gateway. And in fact, that gateway is going to be smart enough to know that it can participate in a token ring environment, and it can participate in an Ethernet environment. So a gateway translates these packets into an entirely different protocol. Your assignment requires you to do a business network. Businesses tend to be huge. And one of the things we do to manage complexity in the computer business, and you'll see this pattern. We talked about patterns. Patterns are a way of dealing with the same kind of problem over and over, even though this particular problem is slightly different. So sometimes we have a problem where the software is too complex, So we make it simpler by taking a big piece of it and just putting it into one package and forgetting about the details and dealing with that all as just one thing. So the same pattern is called modularization, or sometimes you'll hear it called encapsulation. You encapsulate a whole big piece of your problem and just deal with it all as one thing. So with business networks, any large network, you take a chunk of the network and you just encapsulate it, you deal with it all as one thing. So for example, this room is a nice little local area network. I don't know for a fact, but I bet that this is a local area network. And then there's another local area network somewhere else in this building. And then those local area networks are kind of collapsed into just this building's network. And at some layer on this campus, there's a switch that just says I'm routing packets to building 2 or I'm routing packets to building 3, and I don't care who's inside it. So there's always these hierarchies of abstraction. On your homework, they say, well, I'd like to see a couple of Ethernet networks, I'd like to see a couple of switch networks, I'd like to see at least a token ring. So the key for this homework is to be able to show, I've got a big enterprise. I've got some small network, it's connected with some sort of, I don't know, a switch. Then that switch, that small local area network is connected to another small local area network using some other connection. Since it's the same protocol, you could use a bridge, you could have a hierarchy of switches. And then it says, I want you to show that there's a token ring on this in this business as well. Maybe that's the old building that they haven't upgraded yet. But I need to make sure that network is talking to my other networks. So you've got to connect that up. I'm going to be looking for your appropriate use of these devices. When is the switch the right thing to use? When is a router the right thing to use? When is a gateway the right thing to use? And since we're kind of, we're just skating along the surface of networking here, it's not a real critical thing. But I'll tell you right now, if you try to connect a token ring to a switch network with a switch, something's wrong there. That's just not going to work. This is really cool work. Just in terms of, switch gears a little bit, in terms of careers, if you're really good at networking, that's a great career. It's every business is networked now, and every device on the planet sooner or later is going to have a network interface. So if you understand networking, it's a great career. It's also, in terms of technical, there's a lot to it. Networking protocols are one of the few things that we can test to know that they're right, and you can simulate networks to make sure it's correct before you install it. The other neat thing about networking, as we talked about, is it intersects with architecture. So if you want, there's always a physical component to networking. If you want to have a network that works in a building and you want to use it wireless, you have to understand radio frequency stuff. It's like, have you ever thought about how to make sure an orchestral hall has good audio? There are some orchestra halls where you can sit in any seat in the house and you can hear everything. It's a really cool science of understanding how all the waves bounce around inside that space so that you get uniform coverage. Wireless networking is the same way. You think, where do I have to put my antennas to make sure there are no dead spots? It's kind of like sculpture. So if you're interested in networking, there's a track of networking classes at ECC, and there's all sorts of great careers here. Any questions about any of this stuff, or about the homework in this area?
On the homework, the only question I have is with a token ring,
Yeah?
how do you have a server computer?
It doesn't matter. Any one of those devices on the token can be a server or a client.
Well, wouldn't that server be the one that connects to your gateway?
Not necessarily. Usually it's just a network device. In fact, these days, it used to be like I drew it there, the machine, the computer itself had 2 NICs. These days, most computers are built with an Ethernet NIC built in. So what you'll see is a device that has a token ring in and an out and an Ethernet port. So what's inside this thing? If you expand that out, you've got some sort of token ring device, and you've got a gateway built into the device. So that way I can hook a laptop up. I don't have to go find some laptop that understands token rings somewhere. Or I can hook up a server that has NICs on it. And I can work in a token ring environment.
Yeah, I was like, okay, server, has to have a server computer, and I was like, so just like a master computer with the others all attached, or, I mean, that's basically a star if you realistically look at it.
Again, in a token ring network, all of the devices are equal.
Okay.
Each one receives packets from the guy upstream and sends them to the guy downstream. Now, in terms of servers, now these days, a laptop that has a wireless interface and a jack, it has 2 NICs on it. And if you watch a laptop wake up and connect to the environment, if you plugged it in, you'll see it has 2 MAC addresses, it has 2 IP addresses, it has 2 NICs. A server class machine that has to pump a lot of data, quite often will have 4 NICs or more. And it gets real complicated. If you have a device that has to pump a lot of data, you have to connect up a bunch of networks, because, you know, even at 10 gigabytes a pop, that's still not enough bandwidth. So these days, about the only thing that can distinguish a server is how much money you spend on it and how many NICs it has.
Yeah, because I use my laptop as my server for my PS3.
Yep.
Everything I download to my laptop, I can just transfer to my PS3 to the server.
I like using laptops as servers because they've got built-in battery backup. You know, you get a failure and the laptop's already designed to have battery backup. You don't have to go buy a, what do they call those things? Uninterruptible power supply. Built in. It also has its own display. Depending on whether they design the laptop right, you can close the display and it shuts down that part of it and you don't have to spend energy on it.
Shows the sleep.
Yeah.